Okay, in the second video now, what I'm going to do is to look for a pattern in these numbers. So let me go through. I'm going to underline the coefficients here of all our, oops, never wrote the 1 there. This is a 1b squared. So that's a 1, and then for our final row here, it's 1, 3, 3, 1. Okay? Now, there was a mathematician called Pascal, and he actually found this pattern. So let me write this pattern out for you. It forms a triangle, and it's a symmetrical triangle. So what I'm going to do is I'm just going to take these numbers and I'm going to write them next to their expression. So a plus b to the 0 power, we know that was just a 1. So I'm going to write that right here. Then a plus b to the first power, we know that was 1 and 1. So this is a 1 and a 1. Then to the second power, we had a 1, a 2, and a 1. So here, for the second power, it's a 1, a 2, and a 1. To the third power, we had a 1, a 3, and a 1. So this is a 1, a 3, a 3, and a 1. Okay. Now, what we want to do is look for a pattern in these numbers. Well, looks like for the fourth power, looks like we'll be looking for 5 different numbers. So we had 4 here, 3, 2, then 1. And looks like the very first number should be a 1, and it will be. The last number looks like it'll be a 1, and it should be a 1, and it is. Then it looks like the second number, following the pattern down, looks like this should be a 4, and it is. Second to last number looks like it should be a 4, and it is. Now to find this last number here, last number we need to identify the pattern for the whole triangle here. Okay. Now, in order to get this number, what you do is you take the two numbers that are left and right of the space that you're looking for, you add these together, and you get the number in the middle. So 1 and 2 get you 3, 2 and 1 get you 3, 1 and 3 get you 4, 3 and 1 get you 4, so here 3 and 3 will get you 6. Okay? So now we should be able to do the fifth power. So we start with a 1, we end with a 1. 1 and 4 get you 5, 4 and 6 get you 10, 6 and 4 get you 10, 4 and 1 get you 5. So there is the pattern in the numbers, and this is called Pascal's triangle. Okay? What Pascal's triangle will allow you to do is it'll allow you to multiply these out without having to do all this algebra. So, first of all, these numbers will represent the coefficients out in front. So this was the third power, so it's 1, 3, 3, 1. So there's this row here, 1, 3, 3, 1. Okay. Now let's look at the variables. Let's look what happens with the variables. Okay. On this one here, see how we start with a to the third? Well, it's your first term to the whatever the power is. This case is the third power. Then look what happens in the second term. A drops down to the second power. Here, a drops down to the first power. Then a goes to the 0 power or just disappears because a to the 0 power is just 1. So it disappears. Now let's look at what happens with the b term. The b term does the opposite. b doesn't exist in the first term, or that's b to the 0. Then your second term, it's b to the first. Your third term, it's b squared. And then your last term is b to the third. So the a's decrease, the b's increase. Okay? Or the other way of looking at it is the first term counts up, the second term at the end counts down the opposite way. Okay? So let's see if we can't do this example here without doing all the long FOIL and distributing. So since it's to the third power, first we need to identify how to determine what row we're in. So here, notice that the powers here correspond to the second term. Okay? So the power corresponds to the second term. Whatever the second term is your power. Since this one doesn't have a second term, it's 0. Okay? So since this is the third power, let's get our coefficients down. So on this one, our coefficients are to the third power 1, 3, 3, 1. So until you get good at this, what I would recommend doing is writing your coefficients and spread them out. 1, 3, 3, 1. Okay? Now, let's do the x term. So x is going to start off at whatever your power is. In this case, it's the third power. Then it's going to go to the second. Then it's going to go to the first. Then it goes to the 0, or it just disappears. Your next term, our next value is y, and y isn't going to be in your first term. Then you're going to have 1 in your second, 2 in your third, and 3 in your last term. Or you can count it down from the end, 3, 2, 1, gone. Okay? And then in this case, because all your values here are positive, all your signs here will be plus, 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 plus. So now we have our final expression of x plus y to the third power without having to do all this algebra up here. Okay? So let's try a second one. Okay? So on here, let's get our coefficients down first. This is to the fourth power, so here's our fourth power. So our coefficients are 1, 4, 6, 4, 1. Okay? Now, let's throw in our x's. So this is going to be x to the fourth, x to the third, x to the second, x to the first, no x's. Your y term will be no y's, y to the first, y to the second, y to the third, and then this is y to the fourth. Okay, so we got all our variables in there. Now we just have to figure out our signs. Now this one's a little different because it's negative, and the negative isn't attached with the x term, it's attached to the y term. So the y will actually determine what your signs are. Since this very first term has no y's, the sign out in front will be positive because the x's are all positive. Now your second term here has one y. So we have one negative sign here, which if you have one negative and you multiply only one negative value, the answer will be negative. Now your second term here has two y's. So that's going to be a negative and a negative. Well, a negative times a negative is going to be a positive. And your next term you have three negatives. So three negatives multiplied together gives you a negative result. And your last one, you're going to have four negatives. Four negatives makes a positive. Okay? So on here, you can use the y, or that second value, to determine whether it's positive or negative. Or what I like to just know is the very first term is always going to be positive. And then if it's subtraction, the second term in between the first two here, that'll be negative, and then they just alternate through. So whatever works for you to figure out your signs, there are a couple options. Okay. So in the last video, we will cover, in the next set of videos, we'll cover an easier way to generate the Pascals triangle, where we can go directly to the one row that we want.